Okay, problem 6.4.31. I realized that font is really little when I had to snip it out of the Savas work and paste it in here. So it says the logarithmic function m of d, maybe I'll write that over here, the m, oops, hello, the m, struggle bus continues, the m of d equals 5 log, and there's no base, so that implies that it's 10 of d plus 2. Remember, this 2 is outside, so it's like the log is just of this d part. I like to put parentheses in there to help me emphasize that. So the d is the diameter of a telescope, the lens, I think. And then the m is the magnitude, how strong it is. So A says find the limiting magnitude of a telescope having a lens of a diameter of 40. So for this first A, we're just taking a 40 and putting it in here and then going to work that out. So I'll go ahead and just demonstrate that on Desmos. I mean, if you have a calculator, by all means use it. Anything that has just a basic log key on it will work. But since you're obviously doing this on the computer, you can get to Desmos. So I will just demonstrate over here that if I said 5 log, again, I like to put this in the parentheses so that I make sure it doesn't do the log of this plus 2 on the outside. So I've got 10.01-ish. And if we go back there then, so, and it said round to the nearest whole number, so 10.01, that's why that 10 right there. Then it says find the equation of the inverse. So the inverse, if you remember how that works, you take the, where it says m equals the 5 log d plus 2, whoops, not base d, my bad, base 10 of d plus 2. And now you're trying to solve it for this d. And whenever you have a variable inside, it's the argument of the log, then you have to rewrite this as an exponent problem. So remember, this is base 10. We got to get the log alone before we change it to an exponent. So the first thing is we're going to subtract that 2. So now we've got that equals the 5 log base 10 of d. Then divide by this 5 to get the log part all alone. So then I've got like that. So now I've got the log of the d equals that whole m minus 2 over 5. And then finally, now to finish this off, remember this is base 10. When your variable is here and you've got your log expression all alone, that's now your clue to change to an exponent problem. So my base 10 to this whole power, so that whole m minus 2 over 5 is the exponent here, equals my d. And so remember, this is like changing to the inverse. So that's why they write it this way. My magnitude is what is being put into the formula, and it equals the diameter. Sometimes they'll write this in an inverse format, which would look like that instead of this format. But that's how that works to find the inverse formula for this original problem. Now again, what's happening here is I know my magnitude, but I'm trying to find the diameter of the telescope, the diameter of the lens. So then the next question that leads us right into part C is why would we want the inverse? And it's what we just said. So we're trying to find, we don't want to find we're trying to find the diameter, and we know the magnitude. So this one says we're trying to find the magnitude. No, we're putting the magnitude in, so we know that. Find the diameter, yes. They know that, and the diameter of the lens is, so astronomers will use the inverse function to find the diameter. What's different here? The lens is needed when they know the limiting magnitude, as the inverse uses the diameter of the lens as the input. No, the magnitude's the input. So the diameter is not the input. And then the last one just says that the inverse functions to find the magnitude. Again, we're not finding the magnitude, we're finding the diameter. So the correct one on mine is right there. We know the magnitudes, we're putting it into the formula and finding the diameter. All right, D. Use that inverse function now, specifically either like where we found it there or where it is right here. When we know a magnitude of 13.5, so we're going to put that right in for that M right there. So, oh wait, that's not my final answer. My final answer is right here. So I've got my 10. I don't feel like you can see that. I've got my 10 to the power of M, and they said it was 13.5 minus my 2 all over the 5. And again, to do that problem, I'm just going to jump on over to Desmos, and I'm going to just type that in and see what I get. And let's see. Let me get that Desmos over here for you. And we said we wanted 10 caret shift 6 to the power of, the numerator is 13.5 minus 2. I tend to use a lot of these parentheses just to make sure it's doing what I want over the 5. So I've got 199.526231497, you know, depending on how accurate I need to be. This might be a really specific calculator. And so back over here, I would put that answer in here, and it says to the nearest tenth. So I had 199.5, and then it was a 2, so I don't round up, and that's what I'd put in there.